Alright guys, we made it. This is the last notes video of the year. This is basically wrapping it all up, putting all of the conic sections together, going through and being able to identify what type of conic section you have, and then also just practicing completing the square based on what type of problem it is, and then graphing. So here we go. First, I have just at the top of the notes page there, I wrote out the equations of all of the conic sections that we've gone over. I'm not going to sit here and read through it, but it's just nice to have that in one spot. If you're going to be doing the study guide, I would definitely have this set of notes out so that you have all of those together. So we are going to be given some problems. They are not going to be in standard form. And so we're going to have to be able to figure out what type of conic section we have based on just looking at the problem. So these are kind of the steps that you want to go through to figure out what type of conic section it is. So first you want to look at what is being squared. Okay, if there's only one squared term, meaning it's just an x squared or just a y squared, not both, then you know that has to be a parabola, because parabola is the only type that only has one thing being squared. So that's the first thing you check for. Okay. If both things are being squared, then you can eliminate a parabola and move on. So then, second thing, both x and y are being squared. You want to look at the coefficients, so the numbers out in front. If both of them are the same number and the same sign, then you know that has to be a circle. Okay. If they're not, you move on. So now we have the situation where our coefficients are different. So our last step is to figure out if it's an ellipse or a hyperbola. For that, you want to look at the signs. Okay, if the signs are different, then it's going to be a hyperbola. If the signs are the same, it's going to be an ellipse. So let me walk you through this first example here, and then I want you to see if you can practice with the rest of them. So we've got negative 25x squared plus y squared minus 100x minus 125 equals 0. So our first thing is to look, are both the x's and the y's being squared? On this problem, yes. So I can go ahead and eliminate a parabola and move on. Second step, look at the numbers out in front. I've got a negative 25, this would be a positive 1. Now these are obviously different numbers, so I know that this cannot be a circle, so I'm going to move on. So then my last step is to check, are the signs the same or are they different? Here I have a negative 25 and a positive 1. Those are different signs, negative and a positive. So I know that this has to be a hyperbola. Remember, in the equation of the hyperbola, you're subtracting always, right? So you know that that's why this has to be a hyperbola. If they're the same sign, even if they're both negative, can divide that over, and that's when I would get an ellipse. So I'm going to throw the rest of them up here. But for this first one, this was a hyperbola. Okay, go ahead and pause the video here because I want you to try and fill out the rest of these on your own. All right, so when you're good, I'm going to go through the answers pretty quickly here. For part B, both the x's and the y's are being squared, but you can see the numbers out in front are exactly the same. That is when we're going to have a circle. Okay, on part C, you only have the y's that are being squared. As you can see, nowhere else here are the x's being squared. So that's automatically going to be a parabola. And then on the last one, you've got x squared and y squared. The numbers are different, but they are the same sign. They're both positive. So that's an ellipse. At the beginning of this unit, we also talked about, with circles, sometimes you'll have just a point or a non-existent graph. That you cannot really tell just based on the equation, but for us, we're not going to have any of those types of problems in this section, so you don't really have to worry about it, though it may show up again on the study guide. Okay, so then our last thing here. We're going to be given an equation. We need to first figure out what type of conic section we have, so that way we know how to do the completing the square part, and then we're going to go ahead and graph. Okay, so this is putting everything together. As far as the main difference that we have with the completing the square, for circles and parabolas, we want to go ahead and divide. If there's a number out in front of the x squared or the y squared, for circles it'll be the same number. I think it's easiest to divide that out first, whereas for like with hyperbolas and ellipses, we move that number out in front, but we don't divide until the very end. Okay, so that's why it's important to figure out what type of conic section you have first. So for this first one, I'm going to look, it's x's and y's are being squared, right? And the numbers are the same. So I know that this is going to be a circle. So I'm just going to jot this down here, that this is a circle. So with circles, I think it's easiest to just go ahead and divide everything by whatever that number is to begin with. So I'll have just x squared plus y squared minus 5x minus 8y, and then I'm just going to leave this as a fraction. That constant, that's okay. If it's a fraction, it doesn't really matter. We're going to use our calculator to add what we need to. We'll see what we get here. So remember, now we want to group the x's, group the y's, so that we can do completing the square. So I'll have x squared minus 5x plus blank plus y squared minus 8y plus blank equals, and I'm going to move that over, so negative 81 over 4. Okay, so I'm going to do completing the square for both my x's and my y's. On this one, negative 5 over 2 does not simplify, so I'm just going to square both of these to get positive 25 over 4. That's what's going to go in the blank. And remember, I also have to add that to the right side. Okay, do the completing the square with the y's. That gives me negative 4 squared, which is positive 16. So that goes in the blank, and again, I'm adding that to the right-hand side as well. So that gives me, so x, this is kind of weird, it's going to be a fraction, minus 5 halves squared plus, and then y minus 4 squared equals, then when I add up all these things, which again I would just use my calculator here, I get a positive 2. So remember, with the equation with circles, like, we're done here, right? It does not have to be set equal to 1. So as far as graphing it goes, my center is going to be, I switch my signs, so 5 halves, which is 2.5 when I graph it, and then positive 4. And then remember, my radius, I take the square root of whatever I have here, square root of 2, which is about 1.4. So I'm going to go ahead, this is going to be a little weird because it's not nice numbers, but that's okay. So I've got 2.5 and then 4. Here's my center. And then my radius is 1.4. So I'm going to go left, right, up, and down, 1.4 units. So something like this. It's a little high. All right, and there is my little circle. Good, first one down. Next one. So again, first step is figuring out what type of conic section this is. This one's pretty easy right away. I can see that I only have one variable that's being squared, just the y's, so I know that has to be a parabola. With parabolas, just like with circles, if there's a number out in front of that thing that's being squared, I think it's going to be easiest to divide that out. So I'm going to divide everything by negative 2. So that'll give me y squared minus 1/2 x plus 2y minus 1/2 equals 0. Remember, with parabolas, we only want to keep what's being squared on the left side. So I'll have the y squared plus the 2y plus blank equals, and then I'm going to move everything else to the right. So this will be positive 1/2 x plus 1/2. Okay, so now I do the completing the square part. So I get a 1, so I'm going to add that to the right side as well. So then I'll have y plus 1 squared equals 1/2 x plus and then 1/2 plus 1 is 1.5. If I combine my fractions there, I get 3/2, which is probably what I would want to do, because I need to take that 1/2 out now. And then that just leaves me with x plus 3. Okay. So there's my equation. As far as graphing it goes. So graphing parabolas, that's what we've been doing for a while now. So the vertex here is going to be at -3, -1. I know that this is going to open, let's see here. The y's are being squared, so that opens left or right. Since it's a positive 1/2, that's going to open to the right. And then I need to solve for p. So 1/2. So this is going to be kind of weird. P equals 1/8, which is pretty small. So I'm just going to do my best here. -3, -1 is my vertex. I would go right 1/8 units to find my focus, left 1/8 units to find my directrix here, and then I double 1/8, so 2/8 is 1/4. So this is going to be like a really skinny parabola opening up to the right here. All right, a couple more. So first, determining the type of conic section. So I look, both the x's and the y's are being squared. They're different numbers, so it's not a circle. And then I look at the signs. One's negative and one is positive, which means this is going to be a hyperbola. When I write it, the subtraction sign is always in the middle. So usually I go ahead and write the positive stuff first, and then the negative in the end. I might have to switch it back, but I usually like to switch to the beginning here. So I'll start with the y squared. Remember, for hyperbolas and ellipses, this is where you move that leading coefficient out in front, but you don't divide by it, okay? So with the y squared, this is kind of weird because there's no y term. So I'm just going to take the 1 out in front and keep the y squared. But I'm done with the y's. I won't have to do completing the square with those. So then the x's, I'm going to take out that -25. I'm left with x squared plus the 4x, and then I'm going to put the blank. I'm going to move that positive, or move the -125 over so it becomes positive 125. Okay, so the y squareds, that's done. So I just need to do completing the square over here with the x's. So it'll be 4 over 2 squared. So 2 squared is 4. The 4 goes in the blank, but remember with this, you have to multiply by what's out in front. We haven't had to do that yet because we went ahead and divided out that leading coefficient with parabolas and circles. But with hyperbolas and parabolas, you do have to remember to multiply what's out in front. So -25 times the positive 4 is -100. So also on the right-hand side, I have to subtract off 100. So I'm left with, we've got the 1 times the y squared minus the 25 times the x plus 2 squared equals 25. And then with hyperbolas and parabolas, that always needs to be set equal to 1 on the right side. So that's when I'm going to divide by whatever I have here. So I'm going to divide everything by 25 and just simplify my fractions. So I get y squared over 25 minus, here the 25's cancel, I'm just left with a 1 on the bottom. So x plus 2 squared over 1 equals 1. And there is my equation. Remember, this, for the center here, we look at what's being added and subtracted to the x and the y, so careful, this is going to be at -2, 0. So I put my dot there. With hyperbolas, remember that's where you make the rectangle. You draw your diagonals through it, and that's how we graph it. So you look under the x's to tell you how far left and right. So I'm going to go left and right 1 unit. And then up and down, I look under the y's, take the square root. So up and down, I'm 5 units. And then I make my rectangle. Do your best here to draw. I know the arrows are kind of hard when it's this skinny. Ooh. And then since it's the Y's that are first, that tells us that it's going to be opening up and down. So I'm going to be using my vertices here and then approaching those asymptotes. And there's the graph. Okay. Last one. Figuring out what type it is. So again, the x's and the y's are being squared, so it's not a parabola. The numbers out in front are different, so it's not a circle, but they're both positive this time. So this is when we're going to have an ellipse. So again, this is the one where we want to just move the number out in front, but not divide it out. Remember, with ellipses, you always have the x's first, so I'm going to keep those first here. So I'm going to take the 9 out. I'm left with x squared minus 6x plus blank. The y's, I'll take the 4 out, so I'll have y squared minus 2y plus blank, and then move that 59 over, so positive 59 on the right side there. So I'm going to do completing the square on both sides. In this first one with the x's, I get a 9. That goes in the blank. Remember, I multiply. 9 times 9 is a positive 81, so I also need to add 81 to the right side. Over here, I get a 1, so that goes in the blank. Again, I multiply. 4 times 1 be plus 4 that I'm also adding to the right side. So then when I rewrite these, don't forget that 9 still is out in front. So I have 9, and then I've got x minus 3 squared plus, for the y's, there's a 4 out in front, and then y minus 1 squared equals, I add those three numbers together, I get 144. So then my last step, always divide by whatever that number is so that it's equal to 1 over there. So then now I just need to simplify my fractions. I end up with x minus 3 squared over 16 plus y minus 1 squared over 36 equals 1. Good. And then graphing this thing. So the center is going to be at 3, 1. Remember, you just switch your signs with the x and the y. You look under the x to tell you left and right. So left and right, I take square root of 16, which is 4 units. Under the y's, that tells me up and down. So square root of 36 is 6 units. So left and right 4, up and down 6. And then I just draw my ellipse. All right, guys. Good job. You just finished the last set of notes for college algebra. I really hope that you've been watching these videos. I hope that they have helped you. And yeah, that's it. Our worksheet for this last set of notes is just the Conics worksheet that is on my website.